Moving on to the next one. Example 3 and 4. Well, those two examples were long division, and you probably need to be familiar with it and know how to do it. And so I'm hoping that you got kind of a good example. We'll do a couple of long division problems with examples. But I'm going to teach synthetic division as well. Now, synthetic usually kind of means fake. It's not fake division. It's just not long division. It's going to be a little bit simpler for you. So this simplifies the long division process by a linear expression only. So I want you to box in those words, please. A linear expression only. So if I'm dividing by something that looks like this, it cannot have an exponent. Your linear expression is the only option for synthetic division. It will not work like on our example 2. I could not use synthetic division. I would have to use long division because it had an x squared in it. So no exponents in your divisor. So to use synthetic division, you're going to write the coefficients, including zeros, of the polynomial in standard form. We'll talk about this in a minute. You'll understand how much easier this is. You're going to omit all variables and exponents. So for the divisor, reverse the sign. This allows you to simply add instead of subtract. So we're not going to have to remember to distribute that negative through like we did in long division. So here's the example. So we're going to use synthetic division to divide x cubed minus 14x squared plus 51x minus 54. We're going to divide by x plus 2. X plus 2 is linear. There is no exponent in my divisor, so I can use synthetic division. So your very first step is to reverse the sign of the 2. So since it's x plus 2, notice I'm dividing by a negative 2. Okay? Then I'm going to write the coefficients of the polynomial. So I took my 1 that was in front of x cubed. This would be like my x cubed. I took the negative 14 that was in front of the x squared. I took the 51 that's in front of the x. And then I took the negative 54, which is my constant. Okay, let's also check to make sure we have x to the third, second, first, and then this will be our x to the 0 power. Okay, so we have all of our exponents accounted for. So that's how we set it up. I've got this little line right here next to the negative 2 to show that's my divisor. I'm going to do this down instead of going up, like we're not going to have the actual house, so to speak. So the first thing I'm going to do is bring down my leading coefficient. So I brought the 1 down. That's going to be my first step. Bring that leading coefficient down of 1. Now I'm going to multiply. 1 times negative 2 is negative 2. Sorry, that's not where it goes. My bad. 1 times negative 2 is negative 2. It goes right here. We're skipping that very first column. That one's going to go away. Then I'm just simply going to add. Negative 14 and negative 2 is negative 16. Now I'm going to take that negative 16 and multiply it by negative 2. Negative 16 times negative 2 is positive 32. Okay? 51 plus 32 is 83. Okay? 83 times negative 2 is negative 166. I'm going to add those together. Negative 54 and negative 166 is going to be negative 220. I'm hoping. 21, 220. Yes, negative 220. So it says add and repeat until done. We've done that. So we took our first number, multiplied, add. Multiply again, add. Multiply again, add until you're done. Okay? Now, step 4. Rewrite what is left, putting your variables back, beginning with the second highest degree and any remainder. So here's what's left. Okay, now the x cubed is now gone because I've divided it out. So my 1 is now my coefficient of x squared. I don't have to write it. You could write 1x squared, but you don't need to. My negative 16 is my coefficient of x. My 83 is now my constant, and I have a remainder of negative 220. Okay, remainder of negative 220. So also what this tells me is x plus 2, because my remainder is not 0, is not a factor. I can use that same knowledge that we just learned in example 2. I can use it with synthetic division as well. So I know that x plus 2 is not a factor, and I also know when I divide that polynomial by x plus 2, here is my answer. No long division required. Synthetic division is much, much easier, and I would suggest that you learn how to use it, but also please know how to do the long division. Let's do the next example. use synthetic division to divide x cubed minus 57x plus 56 divided by x minus 7. Again, x minus 7 is linear, so we can use synthetic division. So reverse the sign of negative 7. So notice I'm starting with a positive 7. I just changed the sign of what I see there. I'm writing out the coefficients of the polynomial. Notice I have x cubed, but then I go right to x. So I cannot forget a placeholder for x squared. So I have to put that 0 in there. So now here would be my x cubed. Here's my x squared coefficient. Here's my x coefficient, or my x to the first, and here's my x to the 0 coefficient. Okay, so just kind of reminding you of that. So make sure you have that 0 in there. Don't forget that step. Bring down your leading coefficient, multiply it by your divisor. So 1 times 7 is 7. 0 plus 7 is 7. 7 times 7 is 49. Negative 57 and positive 59 is a negative 8. Negative 8 times 7 is negative 56. And then 56 minus 56 is 0. Add and repeat until done. We've done that. And then step 4. Here's our big step. Rewrite what is left and any remainder. So I started with an x cubed. My x cubed is now gone. So my 1 is a coefficient of x squared. My 7 is a coefficient of x. My negative 8 is my constant. I have no remainder, so that is my answer. So this also means that this is a factor of the polynomial x cubed minus 57x plus 56. So if we were to factor that polynomial, x minus 7 would be one of those factors we would factor out. Okay? Example 5. Evaluating a polynomial. Well, what's interesting here is if it tells me to evaluate, in other words, this would be like my x value. So in other words, I am evaluating x equals 3. They're writing it as p of 3 for the following. But what they're telling me right here is by putting that 3 in there, they're just telling me that x equals 3. So instead of having to actually go into my calculator and do 3 to the 5th minus 2x, minus 2 times 3 to the 3rd minus 3 squared plus 2, instead of having to actually do that math where I have to do 3 to the 5th and 3 to the 3rd and 3 squared, I can just use synthetic division and I can divide by x minus 3. So I'm basically taking that 3 and we're going to go ahead and do our synthetic division. I'm going to write it out right here. This we're going to practice. You're going to get to practice it for the first time. So my divisor is 3, which is just basically the number you see right there. That's your divisor. We're not changing the signs. We're just looking at what they've put in for x. We're going to write my coefficients. Well, my coefficients of x to the 5th is 1. I need a coefficient for x to the 4th because I don't see one, so that means it's 0. My coefficient of x cubed is negative 2. My coefficient of x squared is negative 1. I need a coefficient for x, and then I need my constant. Okay, so there it is. I'm going to bring down my leading coefficient, and I'm going to go ahead and go through the process. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 2 and 9 is 7. 7 times 3 is 21. Negative 1 and 21 is 20. 20 times 3 is 60. And 0 plus 60 is 60. 60 times 3 is 180. And 180 plus 2 is 182. Okay, your very last thing, your remainder, which is your very last answer right here, 182, that is your answer. So P of 3 equals 182. If I were to take 3 and put it into this equation right here and solve, it would come out to be 182. Pretty cool, because I think the synthetic division is much easier than doing 3 to the 5th minus 2x to the 3rd, or minus 2, 3 to the 3rd, minus 3 squared plus 2. Example 6, we're going to actually now find all factors. So the first thing I want to look at is, it says, is x minus 2 a factor of the polynomial x to the 5th minus 32? And if it is, write p of x as a product of two factors. In other words, go ahead and completely factor it. Once we discover if x minus 2 is a factor, let's go ahead and completely factor it. And I'm going to show you how to do that. First of all, do we want to start with long division or synthetic division? Well, since our divisor is linear, obviously, I hope you would pick synthetic division. So much easier. So I'm going to write my divisor down here. Since it's a negative 2 in the problem, I'm going to divide by 2. Now, I've got to account for my x to the 5th. I've got that. X to the 5th, my coefficient is 1. My coefficients of x to the 4th, x to the 3rd, x squared, x to the 1st, and then my constant. Okay? So we have to have all those placeholders. Again, it's just a bunch of zeros. Not a big deal. Bring this down. 1 times 2 is 2. Okay? 0 plus 2 is 2. 2 times 2 is 4. You guys can kind of see where this is going. 0 times 4, or 0 plus 4 is 4. 4 times 2 is 8. Add that. 8 times 2 is 16. Add that. And then 16 times 2 is 32. Negative 32 and positive 32 add to 0. So since my remainder is 0, x minus 2 is a factor. Now, here's where I've got to write out my new polynomial. Okay? Because when I divide it, what am I left with? Well, I'm left with x to the 4th plus 2x cubed plus 4x squared plus 8x, excuse me, plus 16. Okay? Now it says, I'm going to erase that little arrow there for you. And it was remainder of 0. It says write this as a product of two factors, only two. I'm not going to ask you to factor this mess right here. Not yet, anyway. So when you're ready to write it as two factors, once we have written our what we're left with, we've put our variables back and we've put our exponents back. I basically put parentheses right around here. And I put my other factor right there. Boom. Two factors. We are done.